We're going to work on 3.4 today, factoring expressions. This is the last section in our Chapter 3 notes that we've been talking about. So I want you to go ahead, pull out your red pens, and fill in these notes for me. The first vocab word we have today is a GCF. I'm hoping that this is familiar to you from 5th and 6th grade, but what is a GCF, class?
Greatest common factor.
All right, it's the greatest common factor between two numbers. Repeat after me. Factors fit into numbers. So you're looking for the greatest number that can fit into both the other two numbers. Then something new that we're going to talk about today is called factoring expressions. This is when you actually pull out the greatest common factors between the two terms. And I'll talk to you about that here in just a minute. But there's a couple more things that I want you to write down in your notes before we get to our lesson for today. What is a GCF? We know that it's the greatest common factor between two numbers. And then we're going to talk about how we're going to find the GCF. I know we've talked about upside down division before. Upside down division is something great to use when there's really big numbers, but typically we're going to have kind of smaller numbers, so we're going to use listing factors when we need to find the GCF. The first thing you're always going to do is find the smallest number, list the factors of that number, then we'll start with the largest number and work our way down the factors until we can find a factor that goes into the other number. And finally, the biggest factor of both those numbers is going to be the GCF. Now, that sounds confusing, so I'm going to show you a couple examples of how we're going to use these different steps to help us. The first thing here, it asks us to find the GCF. So look at your notes that we just wrote down. What does step number 1 tell us to do? Choose the smallest number. So as you can see here, I have an 8 and I also have a 24. Guys, what's smaller of those two?
8.
The 8, okay? Because we're not going to worry about the fact that this says minus right there, okay? 8 is the smaller number. So to the right, I want you guys to go ahead and write an 8. Now let's look at our numbers, or our steps that I just said for finding the GCF. What does step number 2 say? List the factors of that number. So 1 times what will equal 8? 1 times 8. The next number is 2. Can a 2 go into an 8? Yes. 2 times 4. Good job. What about a 3? Can a 3 fit into an 8? No. The next number would be 4. How about a 4?
Yes.
Yes, but look, I already wrote a 4 right there. So I'm actually done. Those are the only factors that I'm going to list. Now I want everyone to look at your notes and read me what step number 3 says. Start with the largest number and work your way down the factors until you find a factor that goes into the other number. So these right here are our factors of 8. What's the largest number we listed over there?
8.
An 8. So right now what we're going to do, it says start with the largest factor and see if it goes into the other number. The other number was 24. Can an 8 go into a 24? Yes, it can. So I want you to go ahead and circle it. That means you just figured out our GCF is 8. As I said, factors fit into numbers. So that means 8 is the biggest number that can go into an 8 that can also go into a 24. That's how you find the GCF. Let's do another example over here. Remember, looking at our rules, we've got two numbers, a 9 and a 15. Start with the smallest number. What's the smallest number?
9.
A 9. So let's go ahead and write a 9 off to the side. What's the first factors that fit into 9? 1 times 9. Excellent. Can a 2 go into a 9? No. What's the next one that can go into it? A 3. 3 times what equals 9? 3. Now, because I have repeated myself, I am officially done with listing the factors. Once we've done that, we're going to go ahead and start with the largest number. What's my largest number that I have over here? Over here for my listing factors.
9.
A 9, okay? So Sierra, can a 9 fit into a 15? No, it cannot go into it evenly. Now it says work your way down. What's the next biggest number? A 3. Can a 3 go into a 15? Yes, it can. So please circle 3. That is going to be our GCF. Does everyone understand how to find a GCF? Okay, so that is just the first step of what we're going to do today in our lesson, finding the GCF. So those are the steps that you need to do in order to find the GCF in an expression. So the instructions here asked us to factor the expression using the GCF. We just talked about how to find the GCF. So our first step when doing this is going to be to find the GCF. Second step, what does it ask us to do for this second part here, class?
Put the GCF outside the group.
Put the GCF outside the parentheses, and then finally it says to take each term and we're going to divide it by the GCF. So I'm going to explain to you by doing this first problem A of how to do a problem like this. First thing we want to do is find the GCF. Of my two numbers, 28 and 18, which one's the smallest? 18. So go ahead and pull the 18 off to the side. Now we're going to list the factors of 18. The first one, 1 times 18. Can a 2 go into an 18? How many times? Not 2 times 6 is 12. 2 times 9. Okay. Can a 3 go into it? How many times? 6 times. Can a 4 go into it?
Yes.
How many times?
No, it can't.
No, it cannot. It doesn't go in evenly. Next number is a 5. Can a 5 go into it? No. The next number is a...
Yes.
And we already did a 6 right there. So we're done listing the factors. Now remember, when I do that, we're going to start with the biggest number, 18. Can an 18 go into the other number, 28?
Yes.
No, it cannot. Let's go down to the next biggest one. How about a 9?
No.
No, a 9 does not go into a 28 evenly. How about a 6?
No. Yes, it does.
How many times does 6 go into 28?
No, 6. 6 times 1. No, it doesn't go in.
It does not go in, okay? 6 times 5 would be 30. So let's keep going. How about a 3? Can a 3 evenly go into a 28?
Yes.
How many times?
No.
No, it cannot, okay? 3 times 9 is 27. 3 times 10 is 30. How about a 2?
Yes.
Yes, because a 2 can always go into it. So everybody circle your 2. My GCF between an 18 and a 28, the biggest number that goes into both of them is a 2. So now we have just done step number 1. We found the GCF. Step number 2 asks me to do what? Put the GCF outside the parentheses. So let's go ahead and we're going to drop it down 2. And now what we are basically doing is we are going to do the opposite of distributive property. Remember in 3.3 we learned how to use the distributive property. Now we're going to learn how to basically do the opposite of it. So it says to take each term and divide it by the GCF. So up here I'm going to rewrite my original problem in the parentheses. I've got 28x minus 18. It has asked me to take each term and divide it by the GCF. Remind me again, what was my GCF for this problem? It was a 2. So I am going to divide this right here by 2 and divide this right here by 2. So basically, whatever number you pull out of the parentheses, you have to divide each term on the inside by the parentheses. So let's do this problem together. I'm going to drop down my 2 that's on the outside. What is 28x divided by 2? 14, and what family is it in? X. So that would be 14x. Now I'm going to drop down my minus sign that I had up there in the original problem. And the next part you want to do, 18 divided by 2. What is 18 divided by 2? 9. And now you have officially factored the GCF out of your expression. Now look, as I said, this is like the opposite of doing distributive property. Let's see if this works out. What's 2 times 14x? 28x. Look, that's that right there. What is 2 times negative 9? Negative 18. All right, so what you have done is the opposite of distributive property. Good job. Problem B. First things first, find the GCF. Guys, what's my smallest number between 4 and 20?
4.
A 4 is the smallest number. What are my factors that fit into 4? 1 times 4. What's the next one? 2 times 2. Now look, whenever you repeat the number, you're done listing the factors. Start with the largest number, 4. Can a 4 fit into both the 4 and a 20? Yes, circle it, okay? My answer is 4. So now that we've found the GCF, we're pulling it outside of the parentheses. 4 times, now if you remember, you're going to take your original problem, and I have to do what to this GCF on every term? I divide it by every single one. So divided by 4 and divided by 4. Now let's go ahead and do this together. The number outside the parentheses will drop down. And if you remember, anything divided by itself always equals 1. Okay, so this basically cancels out and you're left with 1y. And you don't have to put that 1. Drop down your minus. And what is 20 divided by 4? 5. So your answer is 4 times y minus 5. Remember, once again, you're doing the opposite of the distributive property. If we were to go back and double check, 4 times y does equal 4y, and 4 times negative 5 does equal negative 20. That's just a way to double check your work. Factor out the coefficient of the variable term. Do you guys remember what a coefficient is? It's the number part of the variable term. So it's the number that's attached to the variable. In this example, what's the number that's attached to the variable? 1/2. So basically what that does, it takes out the first step. These instructions are telling you exactly what to pull out. So I'm going to pull a 1/2 out. Then I'm going to multiply by everything inside my original problem. If you remember though, it asks me to do what to this? I have to divide each term by 1/2. Whatever you pull out, you have to divide each term by it. Okay, so I'm going to take down my number that I've pulled out of the parentheses, which was 1/2. Now, remind me, anytime you divide a number by itself, you always get 1. So, just remember, if 5 divided by 5 is 1, 4 divided by 4 is 1, 10 divided by 10 is 1, 1/2 divided by 1/2 is 1. So don't get tricked up just because it is a fraction, all right? So what does this right here equal? 1/2, just plain old x. Good job. It's 1x or just plain old x. Plus, this is something we got to remember. Am I allowed to divide fractions? No, you are never allowed to divide fractions. So what this whole crazy thing right there is 3/2 divided by 1/2. Nehemiah, what do I have to do when I am dividing fractions?
Use a little KFC.
Use a little KFC. Good job. Keep the first one, flip the second one, and change the operation. Then remember, you can always cross-reduce. So what does that equal?
3 over 3.
3 over 1, which is plain old 3. So all I'm going to do is bring that down and then box my answer in. So let's do another example just like that. Once again, factor out the coefficient of the variable term. So my instructions are telling me what to pull out. What do I pull out, class? 3/4, okay? So let's go ahead and pull 3/4 out. And then remember, we're just going to rewrite the original problem. But what do I have to divide each term by?
3/4.
By 3/4. You divide by whatever you pulled out of that expression. So I'm going to divide by 3/4 on all terms. Taylor, help me out. What am I going to drop down first?
3/4.
Drop down the 3/4.
And then the parentheses and 3/4 because 3/4 is always will be 1.
Okay, 3/4 divided by 3/4 is 1, so I'm left with just plain old p. Drop down your minus sign. And how do I do this part right here?
You take the 3 and the 2 over and then divide it by 3 over 4. But,
Okay, and we're going to divide it by 3/4. Yep, KFC.
3 over 2 and 4 over 3.
Excellent.
You cross multiply the 3 and the 3 and the 2 and the 4. And the 2 and the 4 make 1 and 2.
Excellent. And what do you get?
1/2. Or 3. 2.
What do you get?
2.
Okay, that is correct. Now, if you wanted to check your work once again, you can multiply these, and hopefully, if you get that, then you know you did your work correctly. Okay, so that is how you factor out a fraction. Next up, factor out the coefficient of the variable term. For this next one, we still have the same instructions, asks us to factor it out. The only difference is I am factoring out a decimal. So what is my coefficient?
2.5.
2.5, because that is the number part of my variable term. Now you're just going to rewrite your original problem exactly like that, but what do I have to divide out of each term? 2.5. Whatever you bring out, you have to divide by it. Okay, so I'm going to take my 2.5 and drop it down. So the first step I'm going to do here is 5 divided by 2.5. Who knows what 5 divided by 2.5 is? William, what do you get? What is it? 2. Okay, it's just a plain old 2. Drop down your plus sign. And class, what is 2.5m divided by 2.5?
0.
Not 0. 1. Anything divided by itself always equals 1. 1 what?
M.
1m. So remember, you can write 1m if you want, or you could just write plain old m. And that is how you factor out a decimal. It's done very much the same as factoring out any kind of number. Number 4, factor out the indicated number. So this is specifically telling me what to factor out once again, so I don't have to find the GCF this time. Factor -4 out of -4 plus p. So we're going to go ahead and put the -4 on the outside of the parentheses. And remember, what you do now is rewrite the original problem, and I have to divide by what in each term? Not 4. -4. Because I pulled a negative out, I have to divide by a negative each time. All right, so let's drop down the -4. Class, what is -4p divided by -4? It's p. Okay, 1p, because remember, this cancels out and just gets a 1. All right, so the next thing we're going to do, we are bringing down our plus sign. And if I am taking 10 divided by -4, is that answer going to be positive or negative? Negative, because anytime you divide by one negative, you're going to get a negative. What is 10 divided by 4?
2.5.
2.5.
Negative 2.5.
Okay, now, when you get to this, if you ever put this on a quiz or a test, I will take a point off. Show me, I don't want a plus next to a minus. What does that mean?
Negative.
Anytime you are adding a negative, that always means to subtract. All right, I want you guys to try to do problem B on your own. All right, I saw a lot of very good work. So we know that we're taking the -5 out of -5d plus 30. Remember, show me your work. We're going to divide everything by -5. So I drop down the -5. Guys, what is this right here? -5d divided by -5?
1D.
Okay, it's just plain old 1d. This is where some people got tricked up. I have plus 30 divided by -5 is what? -6. Now remember, I don't want to see this plus a negative, so what does that mean? Minus. So your correct answer is -5 times d minus 6. Remember, you can always do the opposite. -5 times d is -5d, and -5 times -6 is positive 30. So working backwards is another way that you guys can check your work. The homework assignment that goes with 3.4 is this right here. You do not have to do this over the weekend because this will be your Monday night homework. But if you are an overachiever and just want to get it done earlier, this will be Monday night's homework that has to do with our lesson that we did today.